Welcome back, everybody. I hope you've remembered to do your math and get it turned in. Yesterday's math assignment had some really kind of difficult questions, especially since the very last question, in my opinion, if I were the writer of that book, I would have written that question differently. For example, I would have, in the picture of the cube next to the question, I would have said that the side lengths of that cube were 4 inches. And then I would have wrote the question more clearly. So we're getting used to this new book. This is our very first year with this new book, and trust me, next year's sixth graders probably won't have to do that question. Or if they do that question, I'll make sure they understand it a little better before they get started on their homework assignment. So needless to say, the whole idea is that you need to define the volume of the cube, and we haven't even learned that yet. We haven't really even talked about that yet. So if you had to look in the back of the book at the answer to kind of figure out what it was, that's fine. But one of the better ways to go about solving that kind of a problem before you give up and look in the back of the book is to try to do a little research within your book, okay, before you look at the answer. So like earlier this week, I was talking about the table of contents in our math books, and I was talking about using the index in the back of the book. So I'm going to just go through that really quick with us here. So what we need to do, big ideas. Okay, big ideas. We're going to open the Big Ideas math book online without even logging in. Remember, all you have to do is go to Big Ideas and then click here, View Easy Access Materials. And remember, that gets you to a free version of our books, should we have forgotten our book at school. And as a matter of fact, I'd almost prefer we leave our math books at school and use this digital version at home if you have access to the internet. So while we're waiting for this to load, just imagine your cube. Okay, we've got a cube, and this cube has a height, doesn't it? And it has a length, and it has a width. Modeling Real Life is our book. So there are 3 dimensions in a cube. So in other words, a cube is 3-dimensional. And so that's something we need to remember when we're talking about volume. It kind of helps us remember what the formula is actually. It's a little way to help. So what I would have encouraged you to do, and some of you did come in and ask for help on this question, and I did guide you to the index. So I said, okay, let's flip through your index here and see if we can find the keyword volume. Volume. Okay, so is it here? I think it is. See right here, volumes, it's in the V's. Do you see where it says volumes of cubes finding, page 326? Okay, so then you would have flipped back into your book to page 326, and in there, then you would have seen that has some information about volumes. And some of you did come in and talk to me about this. As a matter of fact, one of the little gals even called me at home last night, talked to me on the phone because her mom has my phone number. Not all your parents have my phone number, but if they did want it, they could have it. They just have to ask me. Okay, so I directed the kids to this square, right? This is a square, this is a square. It is a 3-dimensional cube, and the volume of a cube has a special formula. Side lengths to the 3rd power, side length cubed. So if we would have done 4 times 4 times 4, we would have came up with that answer of 64 that is in the back of the book. Okay, so that tells me that that cube should have had instead of X inches, they should have wrote 4 inches to demonstrate the fact that the cube's face has a side length right here of 4 inches, and that volume of a cube is side length cubed. Now, a volume of a rectangle is different, though. If we had a Kleenex box and we had to find out how many square cubes were in it, that's distracting. Okay, so if we had a Kleenex box and we had to find out how many cubic units were in it, we would have to take the length times the width times the height, because are all the side lengths the same in a rectangle? No, that's why we have to do volume equals length times width times height for rectangles. But if we have a square, they're special because every single side length, the width, and the height are all going to be exactly the same. So we can shorthand it and just say volume equals side length cubed, okay? So that being that, don't freak out if you're not done with your math and you still want to ask me some questions today. You could come and see me during your study hall. That's okay with me if you still have questions on how to finish those last few problems in your math assignment. All right, okay. So today, I promised you guys that I would try to make it so you don't have any homework, right? I don't remember if I said that out loud on live TV here or whatever we call this. But I don't want you to have too much homework. And a matter of fact, if we could just get going here, you guys won't have any homework. But I do want to clarify how you're supposed to do your homework assignment. And it is just a worksheet today, front and back. We do not need any paper other than that worksheet. You're going to write directly onto the worksheet with your pencil. So don't get an extra piece of paper out. I just don't want you guys to staple anything to this when it's time to turn it in. So that being said, I would like the teachers to go ahead and pass out our papers really fast. Can't hear you. I'm not going to help you with it.
No, not that.
I'm kind of short one paper, so if Miss Lewis's class has an extra few pages, can someone bring a two of them over here, please?
Yeah, we'll be right over with a couple for you.
Rock on. Okay, just hand it to him.
I sent someone over with extra paper.
All right. Okay, then just keep them up on my podium.
Do you need one?
Yeah, I do. I need one.
No, we had an extra one. Gave it to me.
Perfect. So for some reason, yeah, Danny's going to need one. Okay. And of course, like usual, I was going to use my technology here, and it's just not showing. Okay, so everybody should have their, yeah, put them on my podium, and that's good. Okay, well, I'm going to go back then to square one here and just look up the document I need on the interweb real fast. Because I was going to use my iPad and just talk to you about it on there, but we'll just go ahead and open it. And don't watch because you're not supposed to see all this stuff. Of course. Okay, ladies and gentlemen in Mrs. Franzen's class, let's just remember though today and always, if we're unmuted, we don't get to just visit. All right, so this should be what you're looking at, right? If I'm not mistaken. And can everybody see a worksheet on their side in the different rooms? Say yes. Okay, so let's just take our pencils right now and put our name on our paper. It just seems like with worksheets, they're easier to forget your name on your paper than it is with homework assignments out of the book. So just put your name on your paper now, and if that's given as a direction, then it should have been done. Okay, next to questions 1 through 6. Do we have any math to do? We do have math to do, but we only have to tell which operation is indicated by the phrase. So in this case, our answers should only look like adding, subtracting, multiplying, and division signs. Do we have any numbers to write down? No. I just want you to tell me, does increased mean adding, subtracting, multiplying, or dividing? And we have a little chart in our book on page 207. So let's get our book out. Page 207. Okay, is it open to page 207? Okay, so maybe I lied. I think it's 206 we need to be open to, or 5. One more in front of that. Wrong way, wrong way. Okay. Rebecca, turn that page here. Thank you, sweetie. That's a whole different math book. Okay. Oh, so I really did lie. I lied 17 bajillion times. It's page 210. This is also in your notes. I mean, really, we have those notes. We can look at this chart. So those are your cues. If you don't know for sure what one of those operations would be, then you would look into that chart. Does that make sense? Okay, do you see these questions? Write the phrase as an expression. Let X represent the number. Do we need to solve anything? Does it say evaluate? No, all we need to do is write these expressions that are written in phrase form as a algebraic expression. So for example, we'll just do one together, okay? A number multiplied by 14. This is question 13. A number multiplied by 14. Okay, you're going to just say 14 and then give it a variable. Okay, does it matter what variable you give it? No, you can pick any letter in the alphabet, but just please use lowercase letters, not uppercase letters. Other than that, there's nothing else to solve. All you're doing today in this spot here is you're just going to be writing these equations. There is actually no way to solve those because we only have a little bit of information and we don't have anything set equal to something else. Now let's look at 17 through 24. 17 through 24, we're doing the same thing. It says write this sentence as an equation. Now once they throw that equal sign in, are we able to solve? I don't know, let's check. If you have number 22, for example, 15 multiplied by number X is 60. Okay, Mrs. Lewis said this at lunch yesterday. She said, you know, we've been doing this all along. 15 multiplied by a number X is 60. She said, your old way of doing this used to be like this. Okay, we're used to seeing boxes. Well, a box is just another symbol saying that there's a missing value, and that's what variables do, okay? So that says the same thing. Are we able to solve it once we know a little bit more about the equation? Heck yeah. So on these questions, there are things you need to solve. So you're going to do this, and you're going to solve them. So write the word solve there. Okay? So what would be the answer for X? Right. It takes 4 sets of 15, 4 times 15 gets us to 60. So the missing number in that expression, I'm sorry, it's an equation because there's an equal sign. The missing number in that equation is 4. Very good. Okay, I don't know why my eraser's not working very good. All right. Now we're going to go here. Turn your paper over. Now you're on the page that says, write a phrase for each variable expression. Huh. Do you suppose that they're just telling you to do the opposite of what you did on the other side? Yeah, so they want to have a short phrase. So for example, you would write for number 30, some number r less than 8. Or use that chart that you have your book open to. Look in the subtraction column. What are our options for signaling subtraction? Well, they are subtracted from, minus, difference of, less than, decreased by, ooh, I like that one too. R decreased by 8. So that's what they're wanting you to do. So you would write this. Okay, so having that book open to that page is going to help you write these phrases for the variable expressions. And we cannot solve them because we do not have any more information. So we don't have to have number answers. We just have to have these phrases written for each one of these, questions 25 through 30. Does that make sense? Okay. Now, do you suppose these story problems are story problems that we can solve? And as a matter of fact, if you read the directions carefully, it says, in exercises 31 through 34, match the situation with the equation that describes it. That means this equation is going to go along with one of these story problems. Let's try number 31. You have traveled 10 miles toward your destination. Your destination is 35 miles from where you started. How much farther do you have to travel? So you know how many miles you've went. We know how far the destination is. So do you suppose we have to add 10 plus some number equals 35? Yes, so as a matter of fact, this is the number that we're going to use that expression with. So 10 plus x equals 35. 10 plus x equals 35. And we know that missing number has to be 25. Yeah, you have to have 25 added to 10 to get up to 35. And if you weren't sure, you just do the opposite. So 35, and we know we've already done 10 miles of that 35, right? Okay, so you can always subtract, but Mrs. Franzen, you said use the expression with a plus sign in it. Yeah, that makes sense because when we go like this, that does equal 35. So in this case, x equals 25. So on these 4 problems, you're going to tell me which letter goes with which number, and you're going to also solve. Okay, so we really don't have to solve mathematically very many problems. Just questions number 31 through 34 need mathematical numerical answers. And then also on the other side of the paper, it is 17 through 24. Okay? Yes. 27 what?
This one, pattern for variable expression.
Yep. So it's a division question. 27 is a division question. So you're going to want to look into the division one and then write an expression using one of those phrases. Okay, so if there's any questions, now would be a great time to ask, but I'm going to go ahead and mute and let everybody just work. The rest of this period is for you to get to work on these problems, and you can hand it in when you're done, and you should be done before the end of the period, I would hope, okay? So, all right, math on, everybody. Bye. Okay, what do you need there?